using the triangle to find the measure of any angle. So we have a right triangle here, and we see the hypotenuse is 9, one side is 5, and we need to figure out what is the measure of angle theta. And so what we know is that we have the adjacent side and we have the hypotenuse, and the trig ratio that relates those two things is the cosine. So we know the cosine of theta equals opposite over hypotenuse. And if we want to solve for the angle measure, we need to use the inverse cosine. Remember, the -1 is the symbolic representation of inverse. So we need to figure out what is the inverse cosine of 5/9. And so to do that, we're going to use our calculator. And we have to hit that blue second button and the cosine button to activate the inverse cosine. 5 divided by 9, and we get 56.25. And if you check at the top of your calculator, if you're on an actual calculator, or hit mode, verify which one you're in. So I'm in degrees mode, so this is definitely in terms of degrees. Had I been in radians mode, it would have given me the angle measure in terms of radians. But this is degrees, so 56.25 degrees would be the angle that has a cosine of 5/9. All right, number 8, we've got a right triangle here where we have now the opposite side and the hypotenuse for angle theta. And so we know that the sine relates opposite over adjacent. So the sine of theta, opposite over hypotenuse, I should say. So the sine of theta would equal 7 over 12. So theta then would equal the inverse sine of 7/12. So we hit second sine to bring up the inverse sine, 7 divided by 12. And it gives us 35.69 if I round to the hundredths place degrees. Now remember, if you're in degrees, you always have to have that degree symbol there. All right, next section says find the smallest positive measure of theta rounded to the nearest tenth if the indicated information is true. So we've got the sine of theta equals -1/4. And so if we think about where sine is negative, and this information here, it tells us we are in quadrant 3. So our reference angle, though, so we've got to figure out, what angle measure down in quadrant 3 would tell us this information. And so theta prime would equal the inverse sine of 1/4. We don't need the negative. We know it's negative because it's down in quadrant 3 and sine is negative down there. But to enter it into our calculator, we have to enter it as just the positive 1/4, and that's why we're talking about theta prime, our reference angle here. So if we hit second sine to bring up the inverse sine 1/4, we get approximately 14.5 degrees, because remember it said rounded to the tenths place this time. But we need to put that angle down into quadrant 3. So to get actual theta, we've got to take 180 degrees plus the 14.5 degrees, so that we get 194.5 degrees for the measure of angle theta. All right, number 10, we've got the cosine of theta equals -2/3 for theta between 90 degrees and 180, which tells us that we are in quadrant 2. And so that's why our cosine is negative. And so to find theta prime, we will do the inverse cosine of +2/3. So we'll hit second cosine, 2 divided by 3, and we get approximately 48.2 degrees when rounded to the tenths place. But again, that's in quadrant 1. We need it to be in quadrant 2. So for quadrant 2, the reference angle, we do 180 degrees minus the reference angle. And so we do 180 degrees minus 48.2 degrees. We're going to get 131.8 degrees. right, next one. The tangent of theta equals -5, and the terminal side of theta lies in quadrant 4. So we know if we're down in quadrant 4, tangent's going to be negative down there. So we're going to find theta prime of to find that, we'll do the inverse tangent of +5. So we'll hit second tangent button to bring up the inverse tangent of 5. And so rounded to the 10th place, we get 78.7 degrees. And so for quadrant 4, we take 360 degrees minus our reference angle of 78.7 degrees. If we do 360 minus 78.7, we get 281.3 degrees. Or if you would do this in radians, because they did not tell us. So in the first 2 problems, they specified in terms of degrees, but here they didn't tell us. So if we calculate that in radians, remember on your calculator you hit mode and go down, highlight radians, hit enter, and then second mode will quit you out, so that now you're in radian mode. Now if I do second tangent to bring up the inverse tangent of 5, so in terms of radians, theta prime, so the inverse tangent of 5 is 1.4 radians. And so we would do 2 pi minus 1.4. So 2 second, and the caret is how we get our pi, minus 1.4 gives us 4.9. So in degrees, it was 281.3 degrees. In radians, it's 4.9 radians. All right, so next one, the sine of theta equals 8/10, and the terminal side of theta lies in quadrant 2. So we are looking for theta prime, our reference angle here. So the inverse sine of 8/10. So if I do this in terms of radians, since I'm already in radians, I'm going to get approximately 0.9 radians. And so in quadrant 2, we do pi minus the reference angle. So again, second caret is how we get the pi symbol, minus the 0.9 radians. Will give us 2.2 in terms of radians. Or if you do it in degrees. So remember, I'd have to switch back. So I got to go to mode, go down, switch over to degree, highlight that, hit enter. Second mode will put you out of that, take you back to your home screen. And we just do it again. Second sine gives us the inverse sine of 0.8. So theta prime equals inverse sine of 8/10. And so we get 53.1 degrees. And so theta would equal 180 degrees minus 53.1 degrees. And so we get 126.9 degrees. So a reminder, anytime you're looking for the angle measure, that's when we got to use the inverse trig functions. So inverse represented with the -1, so the inverse sine. And on your calculator, you got to hit that blue second button and then press the corresponding trig function.